Hey, what's going on, guys? In this video we are going to see how to solve a first order differential equation. How do you know this is the first order? To find out whether this is the first order or not, you have to look at the order. If you have first derivative of y, that's first order. And also this is linear if we have y power 1. If you have y square or anything else, it's not linear. So y has to be powered 1 and this one has to be first derivative. Now first of all, when we solve linear first order differential equation, we have to bring this one in a standard form. Now this is in a standard form. To check this one, you have to look at the general pattern. Standard form of the linear first order differential equation should look like this: dy by dx plus we have to have a function of x multiplying y that is equal to another function of x. Now if you compare this one with this y prime is same as dy by dx, so this is okay. Now p of x multiplied by y, here we have a function of x multiplying this one with y, and then other side of this equation we have a x. So this is already in a standard form. Now we can go ahead and calculate, we can solve this problem. Now in order to solve this problem, first of all we have to find out the integrating factor. To find out the integrating factor, you can call this one as mu. Mu is equal to e power integral of p of x dx. Now here you can see p of x is the value that's multiplying y, and here you can see what is the value that's multiplying y. 2x is multiplying y, but here we have negative. We have to include that negative also, because in the standard pattern we have to have positive. Since we have negative, it means p of x is negative 2x. So from this one we know that p of x is equal to negative 2x. Therefore we have to apply this negative 2x in this equation to find out our integrating factor. So mu is going to be equal to e power integral of negative 2x dx, and negative 2 is a constant, so we can move that one to the front. So e power negative 2 integral of x dx. Integral of x dx is going to be x squared divided by 2, and the denominator 2 and this one cancels each other. Finally we will end up with e power negative x square. Okay, and also we will have constant, but when we do the integrating factor we don't have to worry about the constant, because after we find out the integration factor we are going to multiply the whole thing by the integrating factor, e power negative x square. And even if you multiply this one with constant, we will have constant both sides, so the constant will cancel anyway, so we don't have to worry about constant. Just multiply with this value both sides. In that way we will end up with e power negative x square y prime minus 2xy e power negative x square, that is equal to x e power negative x square. Okay, now the purpose of finding the integrating factor is when you multiply this whole thing by integrating factor for a first order linear differential equation, if you take this part alone and do the derivative, this is dy e power negative x by dx. I put dy by dx instead of y prime, so dy by dx times e power negative x, and if you take the derivative of this one you will get this one back by product rule. Okay, and that's why we don't have to worry about the second part. After we multiplying by the integrating factor, we get rid of this one always. When you do more problem you will get to know this, and we just take the first term and equate that one to this one, x e power negative x square. Now what we have to do is we have to separate this d over dx, and we will have y e power negative x and then x e power negative x square, and after that we have to integrate both sides. Integrate with respect to x both sides. So when you do the integration with respect to x, integration and derivative cancels each other in this side, so we will end up with y e power negative x. In the other side, here you usually in this pattern you will do the integration by parts, but for this one, if you notice this e power negative x square, the derivative is outside, right? So you can do the Jus substitution for this one. So if you take u as negative x square and du as negative 2x dx, and then what's going to be this one, if we replace everything in terms of this, we are going to have integration of e power negative x square is u, so e power u and x dx. du by negative 2 is going to be equal to x dx if you rearrange this one. du by negative 2 is equal to x dx. So when we replace x dx, that's going to be du by negative 2. I can move the negative 2 to the front. I mean 1 over negative 2 to the front, because that's just a constant. And I can keep the du right here. And if you integrate this one, you will get minus half e power u, and also plus a constant. Okay. So this is going to be our final answer. And we know that u is equal to negative x square. We had to plug this one back when we put it here. So negative half e power negative x square plus a constant. And finally we have to express this one in terms of y. So let's go ahead and do that. Y is going to be equal to negative half e power negative x square plus constant, the whole thing divided by e power negative x. And that's it. Actually this one is I made a mistake right here. Our integrating factor is e power negative x square. So when I multiply, I should multiply everything by e power negative x square. This one e power negative x square. So this one, divide the whole thing by e power negative x square. Okay. And that's our final answer. I hope this helps. Thanks for watching. And if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too. And don't forget to subscribe. See you next time.